How do we come up with the ground configuration for an atom? What we do is we assign electrons to the lowest energy orbitals, okay? But we just can't pack them all into the 1s orbital because there is a restriction, okay? Pauli's principle says you cannot assign more than 2 electrons per orbital. So typically, to get the lowest energy configuration, the ground configuration of the atom, you pack the electrons into the lowest possible energy orbitals, and the order in which you fill those orbitals depend on the value of n plus L for the orbitals. The lower the n plus L, okay, the more if you put electrons in orbitals with lower n plus L, you attain a lower energy for the atom, typically. Okay, so for a typical atom, the sequence of filling of the orbitals, uh, uh, the sequence of filling the orbitals follows n plus L. Okay, so if you have two orbitals that have the same, or two subshells that have the same n plus L, then you filled the subshell with the lower n first. Okay, this process, this procedure for coming up with the ground configuration is known as the Aufbau principle, or the building up principle. So before we do that, let's just clarify. In a typical atom, in which of these orbitals would an electron have a higher energy? Then you go by n plus L, right? So n plus L for 3p, for a 3p orbital, n is 3, and remember L is a code for S, P, D, and F is code for the quantum number L. If L is 0, you're dealing with an s orbital. If L equals 1, you have a p orbital. If L equals 2, you call that a d orbital. If L equals 3, you call that an f orbital. Okay, so a p orbital would have L equals 1, so 3 plus 1 would be 4. Let's look at a 3d orbital. N is 3, and for a d subshell, for a d orbital, L is 2. Okay, so 3 plus 2 is 5. And then for 4s, N is 4. And for an s orbital, L is 0. Okay, that's 0. That gives you 4. So, in which of these atoms, in the typical atom, in which of these orbitals would an electron have the highest energy? The answer would be 3D. Okay.